Welcome to video 5 for this unit on quadratic equations. In this video, we're going to focus on rational and irrational solutions. Recall that any quadratic equation can be solved by completing the square. Let's complete the square for the general equation ax squared plus bx plus c equals 0. Start by subtracting c from each side. Next, let's multiply each side by 4a. On the left, this gives a perfect square for the coefficient of x squared, because 4a squared x squared can be written as the quantity 2ax squared. 4abx can be written 2b times 2ax. Let's replace 2ax with the letter p. This helps us see how to complete the square. B squared is the constant term that completes the square, so let's add b squared to each side. The left side is now a perfect square and can be written as a squared factor. So, p plus b must be the positive and negative square roots of the expression on the right. Let's isolate p by adding negative b to each side. Now we can write 2ax in the place of p and solve for x. The solution is the quadratic formula. How do we know if the solutions to a quadratic equation are, in general, rational or irrational? Let's think about what happens when we add and multiply rational and irrational numbers. The sum of two rational numbers is rational. Here's one way to explain why it is true. Any two rational numbers can be written a over b and c over d, where a, b, c, and d are integers, and b and d are not zero. The sum of a over b and c over d is ad plus bc all over bd. The denominator is not 0 because neither b nor d is 0. Multiplying or adding two integers always gives an integer, so we know that ad, bc, ad plus bc, and bd are all integers. If the numerator and denominator are integers, then the number is rational. The product of two rational numbers is rational. We can show why in a similar way. The product is ac over bd. Multiplying two integers always results in an integer, so both ac and bd are integers. So ac over bd is a rational number. What about irrational numbers? The sum or product of two irrational numbers could be either rational or irrational. We can show this through examples. The square root of 3 and negative square root of 3 are each irrational, but their sum is 0. Which is rational? The square root of 3 and the square root of 5 are each irrational, and their sum is irrational. The square root of 2 and the square root of 8 are each irrational, but their product is the square root of 16, or 4, which is rational. The square root of 2 and the square root of 7 are each irrational, and their product is the square root of 14, which is irrational. What about a rational number and an irrational number? The sum of a rational number and an irrational number is irrational. To explain why requires a slightly different argument. Let r be a rational number and I be an irrational number. We want to show that r plus I is irrational. Suppose S represents the sum of r and I, and suppose that S is rational. If S is rational, then S plus negative r would also be rational, because the sum of two rational numbers is rational. But S plus negative r is r plus I plus negative r, which is I, an irrational number. S plus negative r cannot be both rational and irrational, which means that our original assumption that S was rational was incorrect. This means S, the sum of a rational number and an irrational number, must be irrational. The product of a non-zero rational number and an irrational number is irrational. We can show why this is true in a similar way. Let r be rational and I be irrational. We want to show that r times I is irrational. Suppose P is the product of r and I, and suppose P is rational. If P is rational, then P times 1 over r would also be rational, because the product of two rational numbers is rational. But P times 1 over r is r times I times 1 over r, which is I, an irrational number. P times 1 over r cannot be both rational and irrational, which means that our original assumption that P was rational was incorrect. This means P, the product of a rational number and an irrational number, must be irrational. Thank you for watching video 5 of 6 for this unit on quadratic equations.